Hi everyone. So I work on stochastic processes which look like this. So the processes go up and down linearly for random amounts of time. So these have been popular models for things like storage, like the amount of energy in a battery and water levels in dams, and also for internet traffic. Specifically, I'm interested in the density of the process at time t. So that's this function f of xt. So there is a PDE which describes the evolution of this density over time, and you can use, and we have used, finite element methods to solve this PDE. The issue with finite element methods is they work really well, they converge really fast to the solution. However, they don't have positivity preserving properties, particularly when there's discontinuities in the solution. And we're working with probabilities, so we need them to be positive. So we're trying to find methods to work around this. If you look at the simplest finite element methods, or finite volume methods, in fact, you can actually view them as approximating the process by a discrete continuous time Markov chain. So effectively, we approximate the green line by the blue continuous time Markov chain. So it approximates, for example, you break up the y-axis into little chunks of height lambda, and you suppose that the sojourn time, or the amount of time spent within these intervals, is exponentially distributed before you jump up or down, depending on which direction the process is traveling. So this is really good. It has a stochastic interpretation, so it necessarily maintains positivity. However, we know that this is the best we can do. We can't create higher order methods than this. So we can refine this lambda and make that smaller, but we can't, unlike the finite element method where you can increase the number of basis functions, you can't do a similar thing here. If we think about what this sojourn time in these chunks lambda represents, we know that it takes exactly lambda amount of time to traverse these sets because they're fixed height and we move at a fixed rate. So really, we don't want to approximate a density like an exponential. We want basically a delta function at lambda. So we exit immediately when we spent lambda amount of time in there. So my current work is looking at, rather than using exponential times, using matrix exponential times to for the sojourn time in each of these chunks lambda. And so they can represent the delta function a lot better, so they should give a better approximation. They also have a stochastic interpretation, so they will maintain positivity. The big issue for us is trying to work out how to turn these processes around. So we can make them go up, for example, but we don't know how to, when there's a change in direction, how to make the density flow back down. For continuous time Markov chains, you can just use time reversal arguments, and that gives you the answer. Here we can't quite do that because we don't have the same interpretations. So that's what I'm working on. Thank you.